Oh, hey, I didn't see you there. I'm Saccharomyces cerevisiae, a type of yeast that can be found mostly on ripe fruits in nature, where I degrade cellulose into sugar, which I then use to ferment into alcohol. Today, I'll be talking to you about biofuels. Biofuel is an organic energy source produced naturally through direct or indirect metabolism of organic biomass. This means that plant or animal matter is digested over one or more steps by greater than one organism to produce organic fuel or a fuel component. Fungi like me have been observed for our uses in biofuel production in hopes that we can create a greener future for our planet, as well as to provide an alternative to fossil fuels, which are being depleted at an alarming rate. There are 4 different generations of biofuel production, but today we will be focusing on the first 3, where fungi like me are involved. The first 2 generations of biofuel production involves converting biomass into sugars and then into biofuels, using yeast and other fermentative organisms. The enzyme cellulase, utilized by a variety of fungi, catalyzes the first step of biofuel production. Cellulase secreted by fungi degrade plant biomass, also known as cellulose, and catalyzes it into sugar. Sugar then becomes the energy source for the next step in production. Yeast or fermentative microbes then ferment the sugar, producing ethanol, which can then be used on its own to fuel engines, but only engines that can handle its corrosive properties, or it can be mixed with other fuels. I'm classified as a yeast, which means I'm able to break down glucose, a 6-carbon molecule, directly into ethanol, a 2-carbon molecule, without breaking it down further into carbon dioxide. My family tree is very large, and I have cousins that can produce biofuels as well. Fungi working with algae in a process known as bioflocculation are known to produce more oil than each species working on their own. This oil is what is harvested to produce biofuels. A common fungal algae pair is Mordiarella elongate and Nanochloropsis oceanica. I can only digest 6 carbon molecules, but yeasts like Pachysolan tanophilus can digest 5 carbon molecules. To increase biofuel production, we can be cultivated together. Research for fungal biofuel production is limited due to the high cost of cultivation, also because biofuels produce 35% less energy than fossil fuels, meaning you need to produce more to obtain the same amount of energy. Some advantages are that biofuel production does not rely on fossil fuels, only naturally occurring energy sources. And biofuel production results in a net zero carbon production. This means that the amount of carbon released through use equals the amount taken from the atmosphere. To recap, yeast can assist in converting biomass into biofuels through fermentation. With further funding and research, they could be used to replace fossil fuels, bettering the environment.